In today's video, you will learn everything you need to know to build a simple full-stack CRUD application using Nextjs and MongoDB. We will build a beginner-friendly note-taking app that will allow you to perform all CRUD applications from a single window. This is a good foundation to get started building a real-world project, and the source code will be on GitHub. We will start by integrating Prisma into our next project and set up our database. We will then focus on setting up our REST APIs within our app directory. Finally, we'll use Axios to display the data to our front end. With that said, let's go ahead and get started. We'll use npx to create a Next.js application. We'll then get a series of questions, and we'll want to say no to TypeScript, yes to ESLint, yes to Tailwind CSS, no to the src directory, yes to the app router, and no to the import alias. So our application is going to come with quite a bit of boiler code. What we want to do is we want to start with the clean page.js. So inside of the page.js, let's just go ahead and remove all of our boilerplate code from within it, and we just want to start with the main HTML tag, and inside of it we want to have an h2 tag saying hello world. Once you save your file, let's go to our global.css file. Within it, we want to remove all of the CSS except for the Tailwind utilities at the top. Now for styling in this video, I'm going to be using Tailwind CSS and Daisy UI. I won't be going into the styling in this video, so feel free to make this project your own, or you're more than welcome to grab the source code from the description below. Back in the terminal, I want to install two front-end utilities. First, make sure you cd into your directory, then type in the command npm I Axios. Axios will be used to make our front-end request. Now we could have used the fetch method in order to make our API request, but I chose to use Axios as it's lightweight and I wanted to gain some experience with it. Then from here, I'll install the Daisy UI dependency. Now it's time to integrate a database into our application. MongoDB Atlas is a cloud-based open source NoSQL database that uses JSON documents with dynamic schemas, serving as an alternative to table databases. A MongoDB Atlas is built on data intuitive model where objects map to code. To get started, go to the MongoDB website and sign in to create a new project. From here, you'll want to name your project. Once your cluster is set up, you'll need to build a database. Choose the free tier or a suitable plan that fits your needs. Also select the region that's closest to you. You'll be asked to enter a password in order to create a user. Once it's complete, we'll want to focus on the connection details. This will give us the information we need to connect to the database using our Next.js application. Specifically, we want to copy our connection string and bring it into our .env file. We'll also need to update our username and password once we bring it in. So inside of the connection cluster, click on drivers and copy the clipboard. If you need to assign additional user roles, you could do so within the database access link. And if you want to modify the whitelist network access, you can do so by clicking on the network access link. Prisma is an object relational mapper that provides several benefits as opposed to using the database directly. It makes the database schema easier to understand and work with. When working with MongoDB, Prisma generates TypeScript or JavaScript models that represent your data structure, ensuring type safety throughout your application. This feature helps catches errors at compile time, reducing the likelihood of runtime errors and improving your code reliability. So in the terminal, let's start by typing in the command npm install Prisma, and be sure to include the save dev. Then let's run Prisma init. This will initialize a Prisma directory with the prisma.schema file inside of it. Go ahead and open that file and you'll notice that there's a default provider within our database already set up. Let's modify it to MongoDB. Here we'll add our Prisma model name post, which will represent a collection in MongoDB. It has an ID field that automatically generates a unique identifier. We'll include a title and description field. Both will be strings, and we'll also capture the created and updated time in the event we wish to do something with it later. Now let's open the .env file and we'll notice our database URL variable. Let's remove the default connection string and replace it with our MongoDB connection string. Be sure to update your username and password here respectively. Be sure to include the name of your database at the end of the connection string. I didn't name mine anything in particular, so it's going to default to test. Now let's sync our application to the database. In the terminal, let's stop our server and type npx prisma generate. This will initiate the Prisma client. The Prisma client is generated from our Prisma schema and is unique to our project. Now we want to push our schema to the database by typing npx prisma db push. If we navigate back to our MongoDB Atlas, we'll see our schema is in our database, so we know it works. We want a way to access our Prisma client throughout our application. So back in our main directory, let's create a folder named libs, and inside a file named prismadb.js. Here we're going to create a global variable of our Prisma client that's going to allow us to export it and use it throughout our application. The most basic routing primitive in Nextjs is the routing file. Inside of our app directory, create a folder named API. Inside of it, add another folder named post. Inside of the post folder, let's add a file named route.js. The API endpoints in this file will allow us to create and retrieve posts. It's going to be built by Nextjs framework and Prisma using a modern database toolkit. So we'll start with our imports of Next Response and Prisma client that we created within our libs folder. So the post endpoint will handle creating a new post. Once it gets the request, the code extracts the title and description from the request JSON body. It will then use Prisma to create a new post in the database, passing the received data. After successfully creating the post, the code returns a JSON response using Next Response, a utility from Nextjs. In case an error occurs during the post request, the code catches the error and returns a JSON message. The status will be set to 500, indicating that there's a server error. Our get endpoint retrieves all existing posts from the database using the Prisma query function. The fetch posts are then returned as a JSON response using Next Response, providing the post array as the response payload. Just like our post request, if there's an error, we'll return a JSON response as an error message and set the status code to 500. Now let's go ahead and save this file and work on our next endpoints. Now our next API route will need a way to distinguish each post individually. In order to do so, Nextjs allows us to create unique endpoints by putting a bracket around the unique identifier. In this scenario, we're going to use the ID. Let's create another folder with the name of ID surrounded by brackets. Inside of it, let's add a file named route.js. The three API endpoints we will use in this file are get, patch, and delete. These endpoints allow you to fetch specific posts, update its content, and delete it from the database. The get endpoint is going to retrieve a post based on its ID. It'll receive the request in a params object containing the ID. Using params find unique function, the code searches for the post with the given ID. If no posts are found, it'll return a JSON response with the post not found message and update the status to 404. Patch endpoint updates an existing post. It receives the request, takes the title and description from the request JSON body, and obtains the ID from the params object. Using the params update function, the code updates the post with the provided ID, setting the new title and description. If no posts are found, it'll return a JSON response with the post not found message and update the status to 404. The delete endpoint deletes a post. It receives the request and extracts the ID from the params object. Using the Prisma's delete function, the code removes the post from the database. Upon successful deletion, it returns a JSON response with the message confirming that the post was deleted. So that's going to conclude the API endpoints. Now we'll move to our front end. So now we'll turn our focus to setting up our front end. All of our functionality will be within the page.js file. So let's start by creating a folder named components within our main directory and add a file named addnote.js. We'll start with boilerplate code for right now just so that we can have an interface. Once you save the file, let's import this into our page.js file. And if we start our server and navigate back to our local host, we should see the addnote component displayed on our main home screen. So now we'll need to update our addnote.js file in order to have the addnote functionality. We'll start by importing use client, and we'll bring in use state for state management, Axios to make HTTP requests, use router to help with client-side navigation. Inside of our addNote component, initialize the router using the useRouter hook. We will use the router object and its methods for navigation. We have another state variable called input, which are initialized as an empty object. This variable will store the values of the input fields in our form. So we'll need a way to submit our request to our API endpoint, and we'll create a function named handleSubmit. It will make a post request to our API post endpoint using Axios with the input data. If successful, we'll log the response to the console. We'll have the set input functions called to reset the input values, and the router refresh method is invoked to refresh the page. In the handle change function, we will capture any change in the input field that uses set inputs to update the input state. Inside the return statement, we have a form that has an onSubmit method that will receive the handleSubmit function. We have two inputs, one named title and the other named description. Both will have their values set to inputs, title, and description respectively. They also have the onChange method that receives the handleChange function. Now don't forget to include your button with the type of submit. If we save our file and go back to our localhost 3000, we'll see that the addNote component is now on our main home screen. Let's test out the functionality by submitting a note. Let's submit the request and check our database to make sure it went through. If we navigate back to MongoDB and take a look in our database, we'll notice that our first note is now displayed within our MongoDB cluster. Now we'll focus on displaying our notes onto onto our page.js file. We'll start by creating two additional components, one named note.js. Let's go ahead and add our boilerplate code within this file. Now we'll create another component named notelist.js. Within it, we'll add our boilerplate, but we'll also import the note that we just created. Let's save this file and navigate back to page.js. Inside of our page.js file, let's import the note list and display it underneath our add note component. If we save our file and look at our localhost 3000, we should see our note being displayed on the main home screen. So we'll start by updating our note component first. Inside of it, we're going to bring in our necessary import. Then we'll have a note component that receives a note object as a prop. Inside of it, we'll initialize some state variables using the useState hook. Visibility is used to toggle the visibility of the edit form, and note to edit stores the updated values of the note. We'll have an edit form function that'll toggle the visibility of the edit form by updating the visibility state. We'll need a handle submit function, which will be called anytime our edit form is submitted. It's going to send a patch request to the API endpoint with the updated note to edit data. If the request is successful, it'll log the response to the console. If all is successful, it'll refresh the page so that our UI is updated. We'll have a handle change function that's called when there's a change to the input field of our edit form. It will update the note to edit state with new variables. The handle delete function is called when the delete button is clicked. It'll send a delete request to our API endpoint with the note IDs very similar to what we've done with the edit request. We'll have a return statement, and inside of it, first we'll start with the list item that will contain the note ID. Then within the body of our note, we'll have our note title and description. We'll also have two buttons within our component. One on-click method will handle the edit form function, and the other on-click method will handle the delete note. Notice with the delete note, we're passing in the ID. Here we'll have our visibility toggler. This will be the form that's displayed whenever the edit button is clicked. Notice this form will have the on submit method with the handle edit submit function. And our inputs will have the onChange method with the handle change functions. We'll have two buttons within this visibility form. One will submit the request to the database, and one will be to toggle the display of our edit form. So now we'll need to care for our notelist.js file. Inside of it, let's start with our imports. Then we'll need to create a note list component. Within it, we want to pass in the notes prop. Inside of our note list component, we're going to have a return statement, and this will be our unordered list, which will hold the list items of our note. So we want to pass in some JavaScript, and basically here we're looking to map over our notes, and for each note we want to display a note component, and our note component will contain our note ID in addition to the actual note itself. Now we need to save our file and go back to our page.js. Now inside of our page.js, we're going to keep our note and our note list component that we have imported. Then we'll add a function named getData. This will be an asynchronous function that we'll use to fetch the get API in our localhost /API/post endpoint. The cache no store option ensures that the response is not cached by the browser and that it's making a successful request each time it fetches data. We'll have a home component that'll be defined as an asynchronous function. In it, it will be awaiting the data, and we'll store that data in a variable named notes. Inside of our return statement, we'll have the main HTML tag that will have our add note component. Beneath it will be the section tag, and we'll pass in our note list component. Inside of this section HTML tag, we'll pass in the note component. The notes data that we fetched earlier are being passed as a prop to the note list. So now if we save the file and go back to our localhost 3000, we'll see that our note is now being displayed. Let's test out the edit and delete functionality to make sure that it works. So we'll create a second note, and of course we see that it submits onto our screen. If we hit edit, we notice that it is now updated within our list real time. And if we attempt to delete this note, let's see what happens. The note deletes successfully. So it appears that everything is working as designed. I hope you enjoyed today's tutorial. If you did, feel free to give me a like, consider subscribing, and I'll see you in the next video.